Hey Tegan, this is Trig. We ended off yesterday with number 12, so we're on number 13 now. This is Trig Review, day 2. Here we go. Number 13, give the angle measure represented by two rotations clockwise, not counterclockwise, clockwise. So clockwise, I'm just gonna, like, in my brain, just kind of think about what way clockwise is. It's going down, it's going that direction, okay? And two rotations, just two full rotations, okay? How much is one full rotation? 360, but I'm doing two of them. So all I have to do is take that 2 times 360, which is 720, except the only difference is we're going clockwise. If you say 720, it's going to go counterclockwise, but if we're going clockwise, clockwise means negative. So we're going negative 720 degrees. That would be two full rotations clockwise. Okay? Now, if we're doing in radians, it doesn't specify, so I'll let you do it in degrees, but if they say radians, how many radians would that be? 4 pi radians, right? 2 pi is 360, right? So this would be negative 4 pi in terms of radians. Okay? So just keep that in mind. Or you could easily convert 720 to radians like we did on 11 and 12, right? Negative 720 times pi over 180, etc., right? Okay. All right, now 14. Identify all angles that are coterminal with 11 degrees. What does coterminal mean?
Same thing. Like just
the same spot, right? Like if I have like 20, let's say if I have 11 degrees is here in the first quadrant. I want to know, like, if I go one more cycle around, how many degrees will that be, right? So let's start with that. They're asking us two questions here. They say all angles that are coterminal. So I'm going to do all coterminal angles. All coterminal angles, and then one positive angle and one negative angle. So let's do the positive and negative angle first. If I have 11 degrees and I want to find another positive one, what will that be? Another cycle around. 371, right? 371 degrees would be a positive angle. So I take 11. So the positive angle is 11 plus 360. Okay? That's how we found the 371. How do I find the negative angle? Yeah, 11 minus 360. So that's going to be my negative angle. So negative 349. Yeah, is that right? 349? Okay, so there's one positive angle, one negative angle. And those are the same spot as what 11 degrees would be. Now, I want to know how I represent all coterminal angles. Yeah, so this would be 11 degrees plus or minus 360 K on the end, right? Because you're adding multiples of K over, or multiples of 360 over and over and over again. That's what the K represents. So maybe K is 2, and that's 2 circles of 360. Maybe K is 7, and that's 7 circles of 360. So this would be representing all coterminal angles, and then this is one positive and one negative. So there's kind of 3 pieces to that, I guess. Okay? Make sense? Good? Okay. Find the measure for the reference angle of 227 degrees. Where does 227 live? The third quadrant. Okay, so he's down over here, and 227 is this guy. Okay? All right, when it says reference angle, I had somebody use these terms to define reference angle the other day, and I'm like, that is very good. I should use that. It is the bow tie angle. The bow tie angle. It was Caden Williamson in Algebra 2. He was like, oh, it's the angle of the bow tie. And I'm like, exactly right. That's the angle of the bow tie, right? Okay, so the bow tie angle is what a reference angle is. So if I take this angle, the 227, and I make him into a bow tie, like I make his bow tie angle, he's a triangle that looks like that, right? That's like what the bow tie would look like. You connect him like a bow tie, right?
yeah.
And we want to know what this angle is. Question mark. How much that is, right? Okay, so what will that angle be?
227 minus 180.
227 minus 180, and that's going to be like, I don't know, 47 degrees. Is that right? Check me.
Yep.
Let's see. 47 degrees. That's how you find that reference angle. Okay, now let's do a little cheat sheet over here for reference angle. Ready? Okay. In the first quadrant, the reference angle
Regular.
is just a regular angle, right? Because he's just the bow tie. I'm trying to make that a theta and make it look decent. My pen is too thick, I think. No, he's still. Okay, anyway. If he's in the second quadrant, do you remember what you do?
Add, no,
minus
subtract.
180 minus the angle theta, okay? Now, in the third quadrant, what did we just do?
180 plus theta.
Kind of.
Well,
We did theta minus 180. We did it the other way around, right? We took 227 and subtracted 180 from it. Okay, what do you do if it's in the third quadrant? 360 minus that angle theta, right? Doing each one of those things in whatever quadrant you are in will give you the bow tie angle or the reference angle.
0 minus 180 in the third quadrant.
It's theta. The angle minus 180
0 minus 180.
in the third quadrant. Yeah, that's like what we just did, right? Our angle was in the third quadrant. So our angle theta was 227. So we took 227 minus 180, right? Okay, that's exactly what we did. All right, so there's your little cheat sheet. The reference angle is 470. We drew a picture of him. He's good. Any questions on 15 before we move on? Okay, find the values of sine, cosine, and tangent for angle A. So circle angle A, because that's the angle that we're looking at. And we're going to do sine of A, cosine of A, and tangent of A. And all they want us to do is find those fraction-y things that each one is, like opposite, hypotenuse, adjacent, whatever, okay? This is a right triangle. I don't know if you can see the little box in the corner very well, but he is a right triangle, okay? And so we use SOHCAHTOA. If you need to write that down, you can. SOHCAHTOA. There he is, okay? SOHCAHTOA. But we do not have the third side of this triangle. We're missing one of the sides. And which side are we missing? The hypotenuse side, okay? So, how do we find that hypotenuse side? It is a 3, 4, 5, right? So, 60, if I take and divide, each one of these are divisible by 20, right? So, if I divide him by 20, that equals 3. If I divide 80 by 20, that equals 4. And this is a 5 divided by times 20 is what we would have to do to get, so C is going to be 100. Do you see how that is? If that is confusing to you, go ahead and do the A squared, B squared, C squared. Okay? 60, 80, 100. Right? Does that make sense? If it's confusing, go ahead and write it out, A squared, B squared, C squared. Okay? All right? So that's 100. Now, when we put them into fractions, we're going to have to reduce these fractions, right, over here. So we might as well reduce them on here and literally call them a 3, a 4, and a 5. We don't care that they're 60, 80, and 100. Does that make sense? Because when we do it over here, it'll be like 60 over 100, whatever. We're going to end up reducing it to 3 and 5 and 4 and X, etc. So we might as well reduce them on this triangle versus reducing them later, okay? So we're looking at angle A. That's the one that we've circled. Which one is the opposite? The 60 or the 3, okay? So I'm going to do opposite. Which one's the hypotenuse? 5. That's the hardest thing for people to see, and maybe it's just the geometry kids, but they're like, oh, the hypotenuse is the slanted one, right? Right? So the slanted one is this one right here, right? Isn't that the slanted one? Well, kind of. It's slanted, but it's because this is positioned wrong, right? Yeah. So they see that weird. So this is actually the adjacent side. The hypotenuse side is always opposite the right angle. Don't think slanted side. It's the one opposite the right angle, okay? It's the biggest one, okay? So there's that. All right, sine is so, S-O-H, O over H, 3 over 5. Yeah?
Yep.
There's that guy. Cosine, I wrote these too close together. Adjacent hypotenuse? 4 over 5 is cosine. Tangent is 3 over 4. Is that right? Yeah? Okay, there you go. That's all they're wanting for those guys. Okay, good? Make sense? Okay, all right, 7. There's a lot of stuff going on here. They say sine of some angle is 1/3. So what does that tell me? If sine of something is 1/3. What does sine tell you? Like, what did sine up here tell me? Opposite over hypotenuse. So I have a triangle somehow, some way, and the opposite side is 1 and the hypotenuse side is 3. That's what that tells me, okay? This tells me what quadrant I'm in. Where is pi over 2 located?
on the.
Now, keep in mind you can use your unit circle and this packet on your test, right?
It's like,
Pi over 2 is up here, okay? Where's pi located?
Down and left.
The 180 degrees. So this tells me what?
It's in the first
That you are in quadrant
2.
2. You're in quadrant 2. So let's draw a triangle in quadrant 2. Okay, draw a triangle in quadrant 2. Here's my angle. Okay, and then we can label that thing, and we know that the opposite side is 1 and the hypotenuse side is 3. Okay, so which side is the opposite? Like, where does the opposite go? Opposite, this is where angle theta lives, right? So opposite would be 1, hypotenuse would be 3, right? Okay, and we have to find the other side, okay, so that we can find, ultimately, we're trying to find cotangent of theta, right? And cotangent is the opposite of tangent, and tangent is TOA. So cotangent will be AO instead of OA, right? Okay, so that's what cotangent we need. Cotangent, we need AO instead of OA. Okay, so we have to find this guy right here. And to do that, we have to use the Pythagorean theorem. Which side is side C? I always locate him first. 3 is the side C. 1 squared plus, we'll call him x squared. All right, 1 squared is 1, x squared, 9 squared is, or 3 squared is 9. Subtract the 1, x squared equals the square root of 8. Or no, x equals the square root of 8. There you go. X squared equals 8. X equals the square root of 8. Yeah? So this side is the square root of 8. Okay? I don't think I'm going to be real picky. Really, the square root of 8 is 2 square roots of 2. If you get the square root of 8, I'm going to say that that's fine. I'm not going to make you break that one down. Okay? Like we did up above, like a number problem like 3 or something of this packet. We had to break the square root of 48 down like that. I'm not going to make you break the square root of 8 down. Okay? As long as you get that far, that's fine. So adjacent over the, oh, one more thing. And this has to do with the fact that it's in the second quadrant. This is why it's important that it's in the second quadrant, not in the first quadrant. Look at your sides. This is a positive one because he's going up, right? But it's negative square root of 8. That's huge. Negative square root of 8. So I'm going to put like a little note. Don't forget negative. Now, it won't always be negative. If it was in the first quadrant, we wouldn't have to put that negative there. But you see why it is negative? You're going left, which means negative, right? Okay. The 1 is positive, so the 1 goes up. So you need to make sure you have that negative in there if he needs to be negative, right? Okay, cotangent is adjacent over opposite. Which one is the adjacent side? Negative square root of 8, and the opposite side is 1. So we have negative square root of 8 over 1, or just negative square root of 8. Okay? There's a lot of information, but I'm trying to go through everything. Was that okay?
Yep.
Yeah, makes sense? PJ, how are we doing?
Good. Next.
He just lied to me.
I did not lie to you.
Oh, okay. All right. Okay. Number 18, find the values of the 6 trig functions. Bleh. If the angle 3, 4 lies on the terminal side. So what do we do with this? What's the first step? Let's plot the point. 3, 4 is in the first quadrant. So 1, 2, 3, 1, 2, 3, 4. It doesn't have to be perfect. We make him into a bow tie, and then we label his sides. His sides are 3 and 4, and both of them are positive because we're in the first quadrant, as the coordinates are, right? And angle theta lives here. Theta, ooh. Angle theta lives there. Okay, in right next to the origin. Okay, and we want the 6 trig functions. So we want sine of theta, cosine of theta, tangent of theta, and then which one goes with sine? Cosecant. The C's and the S's go together. So cosecant, secant, cotangent. Okay, good. Okay.
Yeah.
All right, we need the 3 sides of the triangle, but we only have 2.
Find it.
Find it. The other one is 5. Or you could use the Pythagorean theorem. If you don't remember that, use the Pythagorean theorem, but it'll save you time if you can remember 3, 4, 5.
So mature.
What's up?
Can you list out the ones that are like there's
Sure.
5?
Yeah. We did that in geometry class, but I forgot we haven't done that here. So these are called Pythagorean triples. And you don't have to list this out if this confuses you, but here they are. 3, 4, 5 is one of them. And any multiples of that, like 6, 8, 10 is the same thing as a 3, 4, 5, right? 5, 12, 13 is another one. Those are the two main ones. Every once in a while you might see an 8, 15, 17. You might see a 7, 24, 25. Or you might see a 9, 40, 41. Those are the 5 main ones. There's more than that, but they get up to be like 137, comma something, and they're really big, so you won't ever use those, okay? So those are the 5 main ones. Really, the top 2 are the 2 that you should remember. 3, 4, 5, 5, 12, 13. Those are the ones that come out perfectly, okay? In a right triangle, all right?
Right.
So let's do sine, cosine, tangent, cosecant, secant, cotangent, okay? All right, if you need to write out SOHCAHTOA, do it. SOHCAHTOA. Okay, SOHCAHTOA. Sine is opposite hypotenuse. Or should we label the triangle? Which side is opposite? 4. Hypotenuse is 5, adjacent is 3. So then you just have to look at those symbols, right? Maybe that helps save some time. Sine opposite hypotenuse. 4 over 5. Cosine adjacent hypotenuse. 3 over 5. Tangent opposite adjacent. 4 over 3. Okay, and then just flip them around for the other ones. So cosecant 5 over 4. 5 over 3. And 3 over 4. There he is. Okay? I feel like these 3 problems that we're doing right now, like 17, 18, 19, are all like exactly the same problem, but worded differently. Exactly the same, because 19 is the same thing. 19 basically gives you all the same information as 17, but just different, like a different way of saying it. Okay, can I zoom in?
Yeah.
Are you still writing? Okay. Find the values of the 5 remaining trig functions given that tangent is -1 and we're in quadrant 4. So let's start with a triangle in quadrant 4. And we make him a bow tie, and there's what he looks like. And the other thing that we know is that tangent of that angle is -1, okay? Tangent of the angle is -1, but what is -1 as a fraction? -1 over 1, and tangent is opposite over adjacent, right? So that means my opposite side is -1, my adjacent side is +1, right? So -1 is the opposite, because here's where theta is. The adjacent side is +1, and then we have to figure out what the hypotenuse is. What? Is a square root of 2. Did you do that using the Pythagorean theorem? Yeah. Also, if this side is 1 and this side is 1, this is a 45, 45, 90, right? Doesn't it have to be a 45, 45, 90 if it's 1 and 1? Yeah? So 1, 1 and square root of 2, okay? Do you want me to write out the Pythagorean theorem? Yeah? So 1 squared plus -1 squared equals c squared. 1 plus 1 equals c squared. So 2 equals c squared and the square root. There's your Pythagorean theorem. Okay, so we've got all the sides. And then I'm going to start listing out. Sine of theta equals cosine of theta equals tangent of theta equals cosecant theta equals secant theta equals cotangent theta equals. You guys have like 10 less problems on your test than like the geometry class does, just because these take forever. Like some of these problems are really super long, right? Like writing them out, oh, they're awful.
And they're harder.
That too. Some of them aren't too bad. Like 20 isn't bad. Find A if I give you these other 2 things. That one's not going to be bad. Find angle theta. 20, 21 aren't bad. And these really aren't terrible. They're just tedious. They just take a while.
Right.
I don't know, right? right? So if you have bad handwriting and you like lose your like
I can't.
99% of math is having a decent size attention span, because when you get to like trig and you have like multi-step problems and your attention span is like that of a squirrel and you can't like move on past step number 1, like then you're just in big trouble, because like it takes 6 steps before you get the right answer, and if your attention span is like this much,
Couldn't be
then
me.
you can't even stay focused long enough to get the right answer, right?
Can't imagine who that would be that you're talking about.
Definitely
Yep,
would be
right.
two people.
Right.
No, not at all.
No, not at all. All right, so should we label opposite? Which one's opposite? Which one's opposite?
-1.
Oh, sorry. Did you just say that, Kelsey? I'm sorry. I can't think.
Lily did.
Adjacent. Oh, Lily did. Hypotenuse. There we go. Okay. Sine. Opposite hypotenuse. Now. Opposite hypotenuse is -1 over the square root of 2. But
You don't want square root of 2 in the
you don't want square root of 2 in the bottom. You remember how to do that? Rationalize. So you multiply by the square root of 2 over the square root of 2, which makes him negative square root of 2 over 2. Yeah?
What?
Yeah? 1 times the square root of 2 and square root of 2 times the square root of 2 just becomes 2. Yeah?
Oh.
Okay, cosecant. Look back at this guy, and we're going to flip him to make cosecant. Okay, what's the flip of -1 over the square root of 2? Negative square root of 2 over 1, or just negative square root of 2. Right? You see that? Okay. Cosine. Adjacent hypotenuse. 1 over the square root of 2, which makes square root of 2 over 2 again. Okay, but we're going to look at this guy and flip him. Is just the square root of 2 over 1, or just the square root of 2. Okay. And tangent, we already know tangent is -1, right? They give us that. What's the opposite of -1? If you flip -1, still -1, right? -1 over 1, -1 over 1, nothing. Okay. All right, now, what type of triangle did I say that this was? A 45, 45, 90 triangle. You guys have your unit circle handy. Look at your unit circle. Look at 45 degrees. Tell me what sine and cosine are of 45 degrees. Square root of 2 over 2 and square root of 2 over 2, except this is 45 degrees actually in the 4th quadrant, so we're really looking at 315 degrees. So look at 315 and it'll be the same sign. Sine is negative square root of 2 over 2, cosine is positive square root of 2 over 2, right? Tangent is -1, right? Okay, so that's on your unit circle also to check. Or if you came up with that, you don't even have to do the sine, cosine, and tangent. You can just pull that off of your unit circle, right? Okay, good? Okay, let's go to some easy ones. Woo! Number 20 is a right triangle, so we are allowed to use SOHCAHTOA all we want. So I'm going to write that on here, SOHCAHTOA, so we know what approach we're doing. And let's label some things that we know. We know that B is 13, so I'm going to cross them out. I'm going to put 13, and A is 76. And we are only finding little a. We're not finding all of them. We're only finding little a. Okay? So to do the SOHCAHTOA thing, we have to have an angle and 2 sides, right? So we have an angle, and we have a side, and then the other side we're solving for, so we have an angle and 2 sides. So we have to label which one we're using. So I have 76, and what is little a in relationship to 76? Opposite, and what's 13? The adjacent, okay? So which trig function are we going to use? Tangent, okay? So we do tangent of 76 is equal to, O comes before A. So it's A over 76. Or no, A over 13, sorry. A over 13. And then multiply the 13 to the other side. So we just do 13 tangent of 76. Do you need to be in radians or degrees?
Degrees.
Why degrees?
Because you're using degrees.
Because you're using degrees. So I'm going to put off to the side over here, degrees, so you can remember. Degrees. That's kind of your little reminder if you're looking at this problem while you're doing the one on the test that you can remember. I need to be in degrees. I need to be in degrees. Okay? What is that? Wow, that's big. 52.1. 52.1. Okay, real quick, let's check. If this angle's 76 and this angle's a 90 degree, what is this little angle right here for B?
14.
14. Does it make sense that 14 degrees would be opposite of 13 and 76 would be opposite of 52?
Sure.
Yeah, because in relationship to 13, 52 is a really big side. But his angle is really big in comparison to the other one, right? So that kind of seems appropriate, right? Okay. 21, finding the angle, and don't say here it is, right? So we have a 3. Is this a 3, 4, 5?
Yes. No.
No.
Why not?
Because the biggest angle is not.
The biggest side is not 5, right? So this side would not be 5 because it's not the biggest side. Okay, so this is not a 3, 4, 5, but it's still SOHCAHTOA. We can still use it because it's a right triangle. What is 3 in relationship to that angle theta that we're looking at?
Opposite.
Opposite, what's 4? Hypotenuse. So which trig function are we using? Sine, and we do sine of what?
Theta.
Angle theta, or you can call it x, I don't care what you call it, equals opposite hypotenuse. So it goes 3 over 4. And now how do I get that theta out of there?
Inverse.
You do the inverse sign. This is the only time you ever use inverse sign is when you're solving for an angle, right? So theta is equal to inverse sine of 3 over 4. Whatever that is.
48.6.
48.6 degrees. Yep, I believe it. That sounds good. Good? Happy with that?
Yep.
Okay, 22. What do we have to get to? 27?
Yeah.
Something? Okay, we're moving right along. Given a central angle of 40 degrees, find the length of its arc if the radius is 15. So here's what we have. We have 15 is here, and we have a 40-degree angle, and it's here. And they want us to find the length of the arc, which is this guy right here. I want to find the length of that pizza crust right there. Okay? So what does a pizza crust represent? What is pizza crust? Like, what is that little thing? What?
A fraction.
It's a fraction of the what?
Whole circle.
What about the full circle though?
Circumference?
The circumference. It's a piece of the circumference. Okay? We've had questions like this before that say, I want to know the area of that slice of pizza. Well, then that's just a piece of the area. So in this case, we're going to use the entire circumference formula, but then we're just going to multiply by the little fraction that we need, right? Okay? So for circumference, it's 2 pi r. So we're going to do 2 times pi times 15. But that would be the entire circumference. I only want 40 degrees of it. So how do I reflect that? But I only want 40 degrees of it.
You take that times 40 divided by.
Yeah, 40 over 360 is the fraction of the circle that I want, which is 1/9. You don't have to reduce it if you don't want to. Do you guys know how to type that into your calculator?
Yeah.
2 pi 15 times 40, and then you can divide it by 360 if you want. What would that be? Something smaller than 15. What is it? 13 something? 12 something? 10 point what? 10.5 inches? Is it inches squared?
No.
No, we're just doing circumference.
Teachers, please dismiss the junior high track members so they can eat lunch.
Okay, 10.5 inches. Okay, good? So just think about what we're trying to find. We're trying to find a piece of the circumference. So we do the whole circumference and then we just multiply it by the piece. Right? Not too bad. All right, now 23 is exactly the same as what I just said, except we're finding the area of that slice. Right? The radius is 1.4. So we have a really small radius this time, and we're doing a 70-degree angle. So I'm going to make him a little bit bigger, 70 degrees. And I want the area of this. I want the area of that slice. So now instead, it's the same procedure as what we did right above. We're just doing a piece of the area. We're just doing a piece of area. How do you find the area of a whole circle? Pi r squared. Okay, so we're going to do pi r squared still. But we only want 70 degrees of it. So we take it times the piece that we want, 70 over 360. Okay, same procedure as what it was above, but we're finding area instead of circumference. You just use your starting formula is just a little bit different. Okay. Okay, did you get an answer? It's going to be a small number because it's the radius is only 1.4. Above it was 15, so if you get a small number, it's fine. 1.19. And that is, so it'd be 1.2 to the nearest tenth.
Yeah.
I'm not going to be real picky. If it says nearest tenth and you give me 1.19, that's fine. Centimeters squared, because it's area. Yep, there you go. 1.2 centimeters squared. Good? Questions about that? Okay, 24, we get into trig graphs, which is like the graph of sine and the graph of cosine. But this is kind of a short, easy, hopefully free points question. Determine whether the following function is periodic. What does it mean to be periodic? Like it repeats, right? It has like the same chunk that repeats. R-E-P-E-A-T-S. There we go. Does it repeat? Question. If so, state the period. How big is it? Okay, so does this thing repeat?
Yeah.
Yes. Like this is one chunk right here. So yes, it is periodic. It has a chunk that repeats. If so, state the period. So how wide is it?
6.
Yeah. Period equals 6. It's not 6 pi, it's just 6 units, I guess, if you want to have a unit on the end there. Okay. Now, you don't have to write this on here, but let's talk about like something that's not periodic. Like let's say you have, you don't have to write this on your sheet. Let's say you have something that's like this. This is called a greatest integer function. This is a step function. Is that periodic?
No.
Why not?
Because it's not the same, like.
It's not at the
this
same
way,
level.
not the
It's the
same.
same like little chunk appearing over time, but it's not at the same level. Does that make sense? So even though that has kind of the same thing going on, it's not at the same level, so it's not technically periodic. It has to be exactly the same as the chunk that was before it, right? Same up and down, y's and everything, okay? So not periodic. So this would be a no, okay? Good? Make sense? All right, so periodic versus not periodic. Okay, let's graph. 25, graph the value of y equals cosine of x, okay? On your unit circle. If you were gone the day that we did this, and Jay was not gone, or he went through and watched the video or something, make sure that you have the graph of sine and cosine and tangent, okay? Get that from somebody or something, okay? These are the normal graph of what just standard sine, cosine, and tangent are before you do things to it, like anything on the graph. So make sure on the back of your unit circle you have that, because you can use this unit circle and this packet on your test, okay? Make sure you have that guy, okay? They want us to graph what just cosine is, but they want us to graph in the chunk from 5 pi to 7 pi. That's it, okay? So I'm going to start at 0, and I'm going to go over here to, I don't know, let's do 7 pi is over here. I don't like that. Let's go, 7 pi isn't divisible by 2. Let's go 8 pi here, and then we'll split them in half. So the halfway point is 4 pi, then I'm going to go 2 pi, then I'm going to go 6 pi. Do you see how I split that? Because it's easier for me to eyeball that.
Yeah.
Yeah? So we want from 5 pi to 7 pi. That's where we're graphing him. So I have those little pink lines. That's where we're graphing from. Okay? And if you graph extras, that's fine. I don't care. Okay? But that's what we want to do. All right?
Okay.
Now, we are graphing cosine. Okay, so let's just start graphing him. He goes up to 1 and down to -1, okay? And one full period of cosine is how big? 2 pi, okay? So from here to here, he's going to have one chunk, right? He's going to do one full thing, okay? So cosine starts up, it goes down, and then it comes back up again. So he's got to come back up and be back up there at 2 pi. Does that make sense? So I'm going to split this 2 pi into quarters. Here, 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 if that helps, right? And he goes down and down and up, and he looks like this. Make him a little curvy so he doesn't look like an absolute value function. That's what he looks like. Yeah? From 0 to 2 pi, that's what he looks like. That's one chunk of cosine. Okay? And we just have to continue him on. So what he's going to do from here to here, he's going to do the same thing again. Okay? So I'm going to split this into 4 chunks, and he's going to go down, down, up, up. And he's going to do that again. Okay? Ooh, I'm getting crazier. Okay? Down, down, up, up. There he is. Okay? And I'm going to do it again. Down, down, up, up. There's my cosine graph. Okay? And I only want from here to here. There you go. That's the chunk that they wanted me to graph. Is that what you need? That's what he looks like. So just keep waving him on. Now, another strategy could be, if you're really terrible at following the tick marks, if you're terrible at following tick marks, do this. Start with the graph. So this is what cosine looks like. Draw him first, and then say, okay, here has to be 0. 2 pi is here. 4 pi is here, etc., right? Like, then put your labels in, right? Does that make sense? Yeah, maybe? So if you're one that, like, can't follow the lines, draw him first and then add the lines in later, right? So you can do that, okay? All right? That was the chunk that we had to graph. Okay? Good, good?
So we need to graph all of it, or do we only have to do
You only had to graph from this point to this point, from 5 pi to 7 pi. That's what he looks like, just that little chunk, right? We graphed additional amount. That's fine. Whatever. Okay? Okay, good? All right, 26, we're writing an equation of a sine function that has an amplitude of 1/2 and a period of pi. So I'm just going to write that out. Amplitude is 1/2, and the period is pi. So A, B, C, D, which 2 are we looking at? Amplitude period tells me A, B, C, D, which ones?
A is 1/2 and B is
A
find it.
and B. Those are the only 2 that we're dealing with. We have to find A and B from the amplitude period, okay? So Maddie just said that the amplitude of the A is still 1/2 because that number just transfers over. But the B is a little bit trickier, right? Okay, what's the formula for period?
2 pi.
For sine, it's 2 pi. So 2 pi over B, and in this case we don't know B, that's what we're trying to find, but 2 pi over B is equal to what they give me, right? Which is 2 pi over B is pi, right? Okay, so you can put them as pi over 1 if you want, and then you can cross multiply. Is that how you guys like to do it?
No.
Yeah? No? Okay, if you don't, then don't watch. So pi times B
This one.
is equal to 2 pi times 1, or just 2 pi, and then divide by pi. So B is 2. Okay? B is 2. All right? And then all we have to do is write the equation. So we have y equals, and we know that A is 1/2 and B is 2. So what's it look like?
1/2 sine.
1/2 sine of 2t or 2x, however you want to write that. Do you need to have parentheses around the 2t?
Yes. No.
You can, you don't have to, right? If you have a c, then you need to have a
Oh, yeah.
parenthesis, but this way you don't have to. Okay, there he is. That's it. That's what we're trying to get to, okay? So the A is given to you, the B you have to work for just a touch, right? Just a touch. Okay?
One more.
27. Oh, is that all we have to go to? 27?
Yeah,
Okay.
keep going one more.
State that we can keep going more. State the rule of secant. If we are stretching vertically by a factor of 3 and shifting pi over 2 units to the left. Okay, so we could label this as A, B, C, D if you want, if that helps. Or we can just slap it into the function. Like, what is stretching vertically by a factor of 3? Like, where does that 3 go?
We should just do ABC.
You like A, B, C, D?
Yeah, in the front.
It's what?
Goes in the front.
It goes in front. It's just 3 secant of t, right? But then if it goes pi over 2 units to the left, in parentheses, it's got to be plus pi over 2, right? Y equals, okay, if you need to do the ABCD thing-ish, A will be 3, and we don't have a B, and we have a C, right? But in this case, since you don't have a B, your C will be like just pi over 2, right? And left equals positive. So it's like there's your stuff. I don't know. That was kind of confusing, but that's how it works into a function. Like, that's how we remember from transformations of functions. Like, if it was just an x squared function, this would be the same thing, right? If you're stretching vertically an x squared function by 3, it would be 3x squared. Now it's just 3 secant. You want to do one more? Yeah, keep going. List the transformations that change this into this. So we just have to decide. We're starting with normal sign, and we have 2 numbers that are being added. Like, what is the 3 doing, and what is the plus 2 doing? So if it helps you to do A, B, C, and D, which ones do we have?
A and C.
A and
C and B, I guess.
A, B, and D.
this is a D.
A.
Because C is in parentheses, D is on the end, right?
We have a B, don't we?
Right?
No, it's T.
B is technically 1, but that's not changing anything, right?
That's nice.
Okay, so it's just A and D. So how does A change him? He's a vertical stretch by 3. Or you can say the amplitude equals 3. However you want to say it, I don't care. Whatever makes sense to you. Is a vertical stretch by 3, or the amplitude is now 3 instead of 1, right? Okay, and what's the D do? What's the plus 2? Up to. And really up to, there's not really, unless you want to say vertical shift up 2 units, you could be really, whatever about it. But up to is fine. So either one of those answers will be fine. Vertical stretch by 3, amplitude equals 3, that's fine, whatever. Okay, that's just an A and a D, all right? 29 is when we get all of this stuff together. So we'll just wait on that one because that one might take a little bit of time. So we'll stop at 28. We'll have, 11 left?
12.
12? 12 left? Yeah, because it would be, yeah. 12 including 29 and 30, Yep, 12 left. Okay, so we'll be okay. All right, except these ones tomorrow are longer than, like, yeah.